Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 24, 2025, which was about 3 days ago. The big hook is that this paper lays out a practical framework to train interactive, user-centric agents with reinforcement learning, and shows that careful reward design and user simulation choices rival raw model scale. The paper is titled UserRL, Training Interactive User-Centric Agent via Reinforcement Learning, and the implications for model training are quite significant. Beyond the framework, the authors find that SFT cold starts unlock learning, trajectory level scoring drives the biggest gains, and stronger simulators help, while open source ones still transfer well. Alright, the introduction highlighted a unified path to user-centric training. Figure 1 shows the full pipeline, which links simulated gym environments to a reinforcement learning policy through a single interact tool. The left block depicts multiple gyms with the 3 operations action, search, and answer wired to simulated users. The center strip presents the standardized interface that funnels choices and feedback into the policy. The right block illustrates multi-turn rollouts, reward remapping into trajectory scores and turn rewards, and token-level advantages used for policy updates. Well, the previous figure outlined the pipeline. Table 1 lists 8 gym environments with their data sources, targeted abilities, and the interface each exposes. The set spans intent understanding, creative and strategic reasoning, math patterns, personalized planning, tool use, and general search. The rightmost column specifies permitted operations mapped to action, search, and answer, so Persuade Gym allows only action, Turtle Gym enables action and answer, while Tau Gym supports all 3. Alright, the previous table mapped abilities and interfaces. Table 3 reports the main results across 8 gyms, separating trained open-source models, raw models, and closed-source references. Equalized R2G leads consistently for QN3 4 billion and 8 billion, with the 8 billion model reaching a mid-50% average because trajectory-level scoring credits supportive turns. Equalized sum lags notably. Trained models surpass closed-source systems in several interactive gyms, including Travel, Persuade, and Intention. Alright, the previous table ranked training strategies. Figure 2 shows 2 comparisons that shape outcomes. The left panels indicate that SFT cold start lifts reinforcement learning substantially, with average scores rising from about 0.31 to 0.53 for 4 billion, and from about 0.35 to 0.57 for 8 billion, and some gyms exceeding 200% gains. The right panels compare simulated users, where GPT-4o during training yields small but consistent improvements, especially on Telepathy Gym. Okay. Figure 2 contrasted cold starts and simulators. Figure 3 presents training curves, with the top panels comparing reward strategies and showing equalized R2G as the most consistent climber, because trajectory level credit keeps learning steady. The bottom left panel shows that SFT cold start raises the starting point and prevents plateaus. The bottom right panel indicates that using GPT-4o as the simulated user yields slightly faster gains and higher peaks, which likely reflects better alignment between training and evaluation. Okay, 2 takeaways stand out. SFT cold starts unlock stable interaction learning, and trajectory level scoring, especially equalized reward to go, drives the biggest gains across diverse gyms. The broader implication is clear. Careful reward shaping and realistic simulators matter as much as model size for practical, user-centric agents. Thanks for listening. I am Alex.